Namaste students. In the past two classes we are solving problems on implicit functions. Hope we have solved all those problems. Today we are going to solve few more problems on implicit functions. Let us take them one by one. It is given if sine of x plus y plus sine of x minus y is equal to 1, prove that dy by dx is equal to cot x into cot y. I have to prove that it is cot x into cot y. Very simple. It is given sine of x plus y plus sine of x minus y as 1. We need to prove dy by dx as cot x into cot y. Let us expand this. Sine x into cos y plus cos x into sine y. That's what sine of x plus y is. Sine of x minus y, sine x into cos y minus cos x into sine y. That's equal to 1. So what happens now? Cos x into sine y minus cos x into sine y gets cancelled. Sine x cos y plus sine x cos y, it is 2 sine x into cos y, that's equal to 1. Now sine x into cos y is equal to 1 by, it is half. Let us take the derivative. First function, derivative of the second, minus sine y into dy by dx, plus second function cos y, derivative of first. What is the derivative of sine x? Cos x. That's equal to 0. So minus sine x into sine y into dy by dx, that will be equal to minus cos x into cos y. Minus cos x into cos y. What is dy by dx now? Minus cos x into cos y divided by, to cross multiply, minus sin x into sin y. You will be getting cos x by sin x is nothing but cot x, cos y by sin y is nothing but cot y. Hence that is the answer. We have got dy by dx as cot x into cot y. Hope you have understood this problem. Very simple way. Expand sine of x plus y and sine of x minus y. Use the formula. Sin x into cos y plus cos x into sin y plus sin x into cos y minus cos x into sin y is 1. Cos x into sin y minus cos x into sin y cancels. So you are left with 2 sin x cos y is equal to 1. Cross multiply 2. Sin x into cos y will be half. So we get sin x into cos y as half. You differentiate that. You have to use Leibniz rule, that is product rule. First function into derivative of second, it is minus sin y into dy by dx. Second function cos y into derivative of sin x is cos x, that's equal to 0 because derivative of half is 0. Keep dy by dx on LHS, minus sin x into sin y into dy by dx is equal to, take cos x into cos y to RHS minus cos x into cos y. So we can define what is dy by dx now. It is minus cos x into cos y divided by minus sin x into sin y. You know, minus minus gets cancelled. Cos x divided by sin x will be cot x. Cos y divided by sin y will be cot y. Hence, that's the answer you get. Let us take this problem. If x root 1 plus y plus y root 1 plus x is equal to 0, prove that dy by dx is equal to minus 1 divided by 1 plus x the whole square. This is what the answer required. So using this you have to prove dy by dx as minus 1 by 1 plus x the whole square. Let us take it like this. X root 1 plus y plus y root 1 plus x as 0. What happens here? X root 1 plus y is equal to minus y root 1 plus x. That's what we get. So you take y root 1 plus x to RHS minus y root 1 plus x. Let us square it on both sides. Square it, x squared into 1 plus y is equal to y squared into 1 plus x. x square plus x square y is equal to y square plus xy square. So you will be getting x square minus y square plus x square y minus xy square is equal to 0. So how this can be written as? I shall write it as x plus y into x minus y. To take xy as common factor, x minus y is equal to 0. Again you can take x minus y as common factor, x plus y plus xy is equal to 0. X minus y is not equal to 0 because basically the condition will be given like x not equal to y. So I will be getting x plus y plus xy as 0. So I take again here x plus y plus xy is equal to 0. Y into 1 plus x, that will be minus x. Hope you have understood this. I have taken y as common factor from these two terms, 1 plus x. Take x to RHS. What is y now? Y is minus x divided by 1 plus x. Let us differentiate this. So dy by dx. Denominator, derivative of numerator minus numerator, derivative of denominator. For 1 it is 0, for x it is 1, divided by 1 plus x the whole square. What you will be getting further? 1 plus x minus x divided by 1 plus x the whole square. Dy by dx will be minus 1 divided by 1 plus x the whole square. So answer is dy by dx will be minus 1 divided by 1 plus x the whole square. One of the important problems it has been given in miscellaneous problems. X root 1 plus y root 1 plus x is 0. You need to prove dy by dx as minus 1 by 1 plus x the whole square. So first x root 1 plus y is equal to minus y root 1 plus x. Square it, you will be getting this expression after simplification. X minus y is not equal to 0 because x minus y is not equal to 0. We have got x plus y plus xy as 0. Y into 1 plus x is equal to minus x. You get y will be minus x by 1 plus x. So differentiating, you will be getting minus 1 by 1 plus x the whole square. Hope you have understood this problem. Another standard question. So very important for the examination. It is given if secant inverse of 1 plus x divided by 1 minus y is equal to a, prove that dy by dx is equal to y minus 1 divided by x plus 1. It's very simple. Let us take it like this. 1 plus x divided by 1 minus y is equal to secant a. Secant inverse when it goes to RHS becomes a secant a. So now take the derivative, differentiating with respect to x. Differentiating with respect to x. What happens? Denominator, derivative of numerator, 1 minus numerator, derivative of denominator. So see here, 1 0 y dy by dx divided by denominator the whole square is equal to derivative of secant a is 0. Now what happens? 1 minus 1 minus 1 minus. So let us consider this here, minus into minus plus. So you need to prove dy by dx as so 1 minus y into derivative of 1 plus x is 1. It is 1 plus x into derivative of 1 minus y. 1 0 y is minus dy by dx is equal to secant a, that is equal to 0. 1 minus y, minus into minus plus, 1 minus, see here, minus into minus plus, it is dy by dx, minus into minus plus, it is x into dy by dx. Okay, you take dy by dx as common factor. 1 plus 6. Take that to RHS, it becomes y minus 1. Hence, what is dy by dx? Dy by dx is y minus 1 divided by x plus 1. That's what the answer. So please see here, minus into minus plus 1 into dy by dx plus x into dy by dx. Dy by dx common factor 1 plus 6 is equal to y minus 1. Let us take one more problem. If cos inverse of x squared minus y squared divided by x squared plus y squared is equal to tan inverse A, prove that dy by dx is equal to y by x. You need to know this. Let us write it like this: x squared minus y squared divided by x squared plus y squared is equal to cos of tan inverse A. Cos inverse goes to RHS, becomes cos. Please see here, let us differentiate that with respect to x. What happens when you differentiate? Denominator, derivative of numerator. Derivative of x squared is 2x. Derivative of y squared is 2y into dy by dx. Minus numerator x squared minus y squared. Derivative of denominator, it is 2x plus 2y into dy by dx divided by denominator the whole square. What is that denominator the whole square? X squared plus y squared the whole square. RHS derivative is 0 because cos of tan inverse A is constant. Cos of tan inverse A is constant. Therefore, its derivative is said to be 0. Please see here. Now, let us multiply 2x cube minus 2x squared y into dy by dx plus 2xy squared minus 2y cube into dy by dx. Multiply that, minus 2x cube minus 2xy into 2x squared y into dy by dx. Next, plus 2xy squared minus into minus plus y squared into 2xy squared plus 2y cube into dy by dx. That's equal to 0. See, this x squared plus y squared the whole square when cross multiplied becomes 0. So what happens now? 2x cube cancels. Then minus 2y cube plus 2y cube cancels. So what is the remaining terms? Take minus 2x squared y minus 2x squared y minus 4x squared y into dy by dx plus 2xy squared plus 2xy squared. 4xy squared is 0. What is dy by dx now? So minus 4x squared y into dy by dx is equal to minus 4xy squared. What is dy by dx? Minus 4xy squared divided by minus 4x squared y. See here, minus minus cancels, 4 gets cancelled, 1x gets cancelled, y gets cancelled, you will be left with y by x. Hence the answer dy by dx as y by x. Hope you have understood this problem also. Please remember, in both the problems, RHS, it is secant A in the first problem and cos of tan inverse A, both are constants, hence their derivative is said to be 0. Remember, it's very, very important, please don't confuse. Let us take next problem. y square into 2 minus x is equal to x cube. Find dy by dx at 1 comma 1. You are asked to find out the derivative at 1 comma 1. Let us take the derivative first. First function, derivative of second. Derivative of 2 minus x is minus 1. Second function, 2 minus x. Derivative of first, 2y into dy by dx. That's equal to 3x square. Now, 2 minus x into 2y into dy by dx is equal to 3x squared plus y squared. Minus y squared, take it to RHS, becomes plus y squared. What is dy by dx? 3x squared plus y squared divided by 2 minus x into 2y. You want dy by dx at the point 1 comma 1. 1 comma 1. 3 into 1 squared plus 1 squared divided by 2 minus 1 into 2 into 1. This 3 plus 1 divided by 1 into 2. You get 4 divided by 2. So dy by dx at the point 1 comma 1 will be 2 is the answer. Hope you have understood this problem. Is given, find dy by dx. If x cube plus x square y plus xy square plus y cube is equal to 81. You need to find dy by dx for this. So just check how to solve this problem. See how to solve this problem. First I take derivative of x cube 3x squared plus product rule, first function derivative of second function derivative of first. Again here first function derivative of second 2y into dy by dx. Second function y squared derivative of first is 1 plus 3y squared into dy by dx. RHS derivative of 81 is 0. Now let us take dy by dx. That's what common factor. X squared plus 2xy plus 3y squared is equal to minus 3x squared minus 2xy minus y squared. So terms independent of dy by dx should be taken to RHS. So what is dy by dx now? Dy by dx minus of 3x squared plus 2xy plus y squared divided by x squared plus 2xy plus 3y squared. This is what the answer we get. Hope you have understood this problem also. So these are all the few problems we have solved in implicit differentiation. Implicit functions are the functions in which y is not directly expressed in terms of x. Hope you have understood all these problems. Please solve these problems again and again. Many of the extra problems I have done, we need to solve them. Now we move on to the next important topic called derivatives of inverse trigonometric functions by substitution. That's very, very important. Derivatives of inverse trigonometric functions using proper substitutions. Substitution. This is what important. derivatives of inverse trigonometric functions by substitutions. Whenever you get some expressions, you need to take proper substitutions. That's very important. So let us have an idea of this expression and what is the suitable substitution. Let us consider a few standard expressions and think of the proper substitutions for them. See, suppose when you have root of a squared minus x squared. So you need to take x is equal to a cos theta or x is equal to a sin theta. So if you substitute that, expression will be simplified. Just for the simplification purpose, we are taking substitution. Suppose when you have root of a squared plus x squared, expression of this form, I have to take x is equal to a tan theta or x is equal to a cot theta. This is the substitution we are going to take. Hope you have understood this. Suppose when you have root of x squared minus a squared, you need to take x is equal to a secant theta or x is equal to a cosec theta. This is the substitution when we have root of x squared minus a squared. Suppose when you have root of a plus x or root of a minus x, in these two expressions, you need to take the substitution x is equal to a cos theta. These are the standard expressions and the corresponding substitutions. If you understand this, you can solve the problems easily. So understand how we have taken substitution. When we take the proper substitution, expression will be simplified. So that we can easily differentiate. So based on this concept, let us solve few problems. And before that, it is better we define the derivatives of inverse trigonometric functions. So let us start one by one. Suppose if you have y is equal to sin inverse x. We don't know the derivative of this. Let us write x is equal to sin y. Hope you have understood this. We have written x as sin y because y is sin inverse x means x is sin y. Let us differentiate that with respect to y. Dx by dy is equal to cos y because we are differentiating that with respect to y itself. What is dy by dx? Dy by dx will be 1 by cos y. What is cos y? Root of 1 minus sin squared y. So we further conclude d by dx of y. What is y? Y is the thing but sin inverse x. 1 divided by root of 1 minus x squared. So sin y, cos y is root of 1 minus sin squared y. So sin y is equal to x. So derivative of sin inverse x is 1 by root of 1 minus x squared. You need to remember this formula. Similarly, let us take y is equal to cos inverse x. What is x? X will be cos y. What you are going to do in the next step? You differentiate with respect to y. Because here x is a function of y. We get minus sin y. Dy by dx is equal to minus 1 by sin y. What is sin y? Formula root of 1 minus cos squared y. So you get d by dx of y. Y is cos inverse x is equal to minus 1 divided by root of 1 minus x squared because cos y is x. So we have derived two important derivatives. Derivative of sin inverse x is 1 by root of 1 minus x squared. Formula is important. Derivative of cos inverse x is minus 1 by root of 1 minus x squared. You need to remember these two formulae. Hope you have understood these two. Let us take y is equal to tan inverse x. What is x is equal to? You get tan y. X is tan y. Find the derivative with respect to y. Dx by dy. What is tan y? You get it is secant squared y. Cross multiply or take the reciprocal. What is dy by dx? See, dx by dy is secant squared y. Dy by dx is 1 by secant squared y. So secant squared y can be written as 1 plus tan squared y. Hope you have understood this. So d by dx of what is y? Y is nothing but tan inverse 6. RHS is substitute 1 divided by 1 plus what is tan y? Tan y is x. So we conclude derivative of tan inverse x is 1 by 1 plus x squared. Hope you have understood this. We will take the next one. Y is equal to cot inverse x. Y is equal to cot inverse x means what is x is equal to? X will be cot y. Let us differentiate that with respect to y. Dx by dy is equal to minus cosec squared y into dy by dx. Minus cosec squared y, because we are differentiating that with respect to y. Take the reciprocal, r cross multiply, dy by dx is minus 1 by cosec squared y. So what is y? D by dx of y. Y is cot inverse 6 minus 1 divided by cosec squared y is 1 plus secant squared by 1 plus cot squared y. Hence we can write 1 divided by 1 plus x squared. So derivative of cot inverse x will be minus 1 by 1 plus x squared. Derivative of tan inverse x 1 by 1 plus x squared. Derivative of cot inverse x is minus 1 by 1 plus x squared. You need to remember we have defined for y is equal to sin inverse y, sin inverse x, cos inverse x, tan inverse x and cot inverse x. Two more. You need to find the derivative of secant inverse x. What is the derivative of secant inverse x? Take x is equal to secant y. Take the derivative with respect to y, dx by dy, secant y into tan y. You take the reciprocal, dy by dx is equal to 1 by secant y into tan y. So you have got formula 1 plus tan squared y, tan squared theta is secant squared theta. So shall I write it as secant y into root of secant squared y minus 1 d by dx of y secant inverse x 1 divided by x root x squared minus 1. Secant y is x. So we have get the formula derivative of secant inverse x is 1 by x root x squared minus 1. Similarly, we take up y is equal to cosec inverse x. What is x is equal to? Cosec y. Let us differentiate that with respect to y. Dx by dy is equal to minus cosec y into cot y. You take the reciprocal. When you take the reciprocal, you will be getting dy by dx as minus 1 divided by cosec y into cot y. Now we can write cosec y into cot y. What is cot y? Root of cosec squared y minus 1. So we get d by dx of y, that is cosecant x, cosecant inverse x is equal to 1 divided by, what is cosecant y? X, root x squared minus 1. Derivative of secant inverse x is 1 by x root x squared minus 1. Derivative of cosec inverse x will be minus 1 by x root x squared minus 1. So far we have derived 6 important derivatives. Inverse trigonometric functions, derivative of sin inverse x 1 by 1 plus x squared, derivative of cos inverse x minus 1 by 1 plus x squared, derivative of tan inverse x is 1 by 1 plus x squared, derivative of cot inverse x minus 1 by 1 plus x squared, derivative of secant inverse x 1 divided by x root x squared minus 1, derivative of cosec inverse x is minus 1 divided by x root x squared minus 1. You need to remember all these formulae along with the proper substitution. Then only you can solve problems on derivatives of inverse trigonometric functions by substitutions. So please learn these formulae, these concepts very well. That's all for the day. Thank you.